Hello, everyone. My name is Zachary Waters, and I wanted to talk to you today about Chapter 17, or blood. What is blood? Blood is a body fluid that circulates throughout the human body through our blood vessels. Its normal pH is between 7.35 and 7.45 at a healthy level, and its temperature is roughly 100.4 degrees Fahrenheit. It serves many functions. It distributes oxygen, it removes waste, transports hormones, it regulates body temperature and its own fluid volume, and blood also prevents blood loss. What is in blood? Blood consists of red erythrocytes, or red blood cells, and they make up about 45% of the total blood volume. Less than 1% of blood is white leukocytes, or white blood cells. And finally, plasma makes up about 55% of blood. Blood plasma. Over 90% of blood plasma is actually just water. The other 10% is numerous proteins, which have many different functions, albumin being the most prominent one, and it makes up about 70% of all proteins. Other proteins include alpha and beta globulins, which are transport proteins, and also gamma globulins and fibrinogen being a clotting agent in blood. Gamma globulins, also known as antibodies, are interesting in their ability to mark cells for death. So opsonization is where antibodies bind to a foreign invader or an antigen or a bacteria. And antibodies will bind to the peripheral proteins on that antigen, and a macrophage, or a white blood cell, will come by in the bloodstream, and it will engulf it through a process called phagocytosis, and it will essentially digest that bacteria and prevent it from doing harm to the body. Debatably, one of the most important parts of blood is red blood cells, or RBCs. And RBCs have a very unique shape. It's a biconcave disc where it almost looks like an inflatable tube without the center punched through. This shape is thanks to a protein called spectrin that gives it that unique shape. Red blood cells also have a very important protein called hemoglobin. And on each red blood cell, there's over 250 million hemoglobin. And each one of those hemoglobins has four different structures, 2 alpha structures and 2 beta structures. And on the center of each one is something called a heme ring. And this heme ring has an iron on it, which holds an oxygen, and that allows for oxygen transport in the body. With oxygen, it's called oxyhemoglobin. Without it, it's deoxyhemoglobin. And with carbon, it's called carbamino hemoglobin. I wanted to also talk about some illnesses in blood. One that many may have heard of is sickle cell disease. The shape of blood, or red blood cells, is essentially changed into a crescent moon shape. And this is thanks to a single amino acid change in the beta chain of hemoglobin. This, of course, leads to many medical issues. Sickle cell anemia, they can rupture and obscure small blood vessels. Interestingly enough, though, this disease is most prominent in the malaria belt of Africa, and malaria attacks the red blood cells in normal people, but the shape of the sickle cell disease almost gives people with sickle cell disease a resistance to malaria because it can attack the red blood cells as well. So that might be why it's so prominent there, as it gives people a resistance to that disease. There's another condition called polycythemia, where it quite literally means too many red blood cells. Now, you would think this would be a great thing, more oxygen, so there would be more energy, but it's actually a very bad thing. It makes your blood more viscous, and it makes it harder for your heart to pump the blood. It could be hard for small blood vessels to get blood in there. It's so thick and moving so slow, so it's bad for your overall health. Another important aspect of blood is white blood cells. They They again make up only 1% of total blood volume, so very small. There are 5 main ones that are fairly essential to the body, but white blood cells fall within 2 categories, granulocytes and agranulocytes. And this is based on their microscopic appearance, where granulocytes appear to have granules on them, and agranulocytes don't. We'll start with the granulocytes, and there are 3 of them in total: neutrophils, eosinophils, and basophils. Neutrophils you will find at the site of acute infections. That meaning you'll find them at places where it's a quick temporary illness that would last about 4, 5, 6 days. They make up a large amount of white blood cells in total. They make about 60%, 40 to 60%. And they phagocytize bacteria. Eosinophils have large, distinct red granules under a microscope, and they make up only about 1 to 4% of white blood cells. Their job is to target and kill parasitic worms by attacking them en masse. They also produce antihistamine, which reduces inflammation in the body. Basophils, the last granulocyte, are antagonists to eosinophils because they release histamine, which causes inflammation. So they're essentially kind of like counterparts. They also cause vasodilation, which promotes blood flow to tissue, and they make up less than 1% of total white blood cells, so very small amount. Then there are 2 types of agranulocytes, lymphocytes being the first one. And lymphocytes have 2 types, T cells and B cells. T cells attack your infected body cells that have already been infected with an antigen or bacteria, while B cells turn into plasma cells and secrete antibodies to seek out antigens and attach to them, opsonization. And they make up about 20 to 40% as well. Lastly, there are monocytes, which perform phagocytosis at the site of chronic infection being one that lasts months or years. And in tissue, they are called macrophages. So when they move out of the bloodstream, they're called macrophages instead of monocytes. And they make up about 2 to 8%. There are also white blood cell illnesses, too. One of the illnesses many may have heard of is leukemia, where there are too many non-functioning white blood cells. So your immune system has a difficult time defending the body because it's almost like not having enough police to defend against an army of criminals, or bacteria in this case. You can get it as a juvenile, and it could be classified as juvenile leukemia, or you could get it as an adult, where it would be chronic leukemia. There is also leukopenia, or too little white blood cells, which is a little bit similar to leukemia. Or leukocytosis, or too many white blood cells, which may be a sign of a chronic infection. There's something else in blood called platelets, which helps your body to stop bleeding. They rush to a site of bleeding to essentially plug it up. Platelets then release, after they attach, ADP to attract other platelets and allow them to attach. This activates something called the coagulation cascade, which then results in prothrombin, which results in thrombin. And thrombin stimulates platelets even further to attach more, to plug up the hole even more. And then that stimulates fibrin, which creates a mesh over the site where RBCs begin to bind, RBCs, red blood cells. Thrombin essentially turns fibrinogen into fiber for the mesh, fibrinogen being that clotting agent in blood. Half an hour later, actin and myosin squeeze the capillary and push out water, and fibrinolysis is the process of breaking down the clots by breaking down fibrin, the mesh, and plasmin, another protein, also breaks up the clot. And something we're all familiar with is blood types, which are an interesting concept. A positive, A negative, B positive, B negative, O positive, O negative, AB positive, AB negative. 85% of people are Rh positive or have a positive blood type, which means they are positive for Rh factor. And this means they have a protein on their red blood cells that kind of gives your body an indicator that it's yours. This, in turn, limits who you can and cannot donate blood to. Those who have A blood type cannot take from B, as they have anti-B antibodies. And if someone who had a B blood type donated to someone who had A, that person, the A blood type person, would be, their body would treat it as if it was a foreign invader or an infection. So that would be terrible, having that into your bloodstream, and could kill you. So O negative can donate to all, whereas it can only receive from O negative. This is due to the lack of Rh factor and proteins on the outside of O negative, which allow it to go to all, but it cannot take from all. And that's about all I had of it for today. Thank you for listening. Have a good one.